Good morning, my dear student. On the behalf of KTHM College Nasik and Department of Chemistry of this college, I am Dr. S.R. Labhade. Welcomes you to the lecture on thermal methods of analysis. Student, in previous lecture we discussed the precipitation gravimetry. In precipitation gravimetry, the analyzed substance is converted into insoluble precipitate. That insoluble precipitate is brought in a stoichiometric form. Then the weight of that stoichiometric form of that precipitate is taken for quantitative analysis of the substance. In addition to this, we also discuss electrogravimetry. In electrogravimetry, the analyte which is to be estimated or analyte which is to be determined is electrolytically converted onto the electrode, and increase in weight of the electrode is required for quantitative analysis of that particular substance. Therefore, precipitation gravimetry and electrogravimetry are the two important gravimetric techniques we already discussed. Student, in today's lecture we discuss volatile gravimetry. Volatile gravimetry is the name given to the thermal methods of analysis. Thermal methods of analysis. Volatile gravimetry, that is a thermal methods of analysis in which, in thermal method of analysis, thermal methods of analysis during heating the sample, the change in physical or chemical, change in physical or chemical properties of a substance is recorded as a function of temperature for identification and estimation of sample. Therefore, volatile gravimetry, that is a name given to the thermal methods of analysis in which the sample is heated, and during heating the change in physical and chemical properties of a substance is recorded as a function of temperature for identification and determination of the sample. That means identification, that means we can qualify, that is we can quantitatively, we can carry out the quantitative analysis of that substance as well as we can determine the amount of substance. Therefore, in thermal method of analysis, both qualitative as well as quantitative analysis is carried out. The best example of qualitative analysis, that is a identification of an organic compound by recording its melting point or boiling point, or a boiling point. This is a physical method of identification of a organic compound. This is a thermal method of identification. That means we can record the boiling point or melting point of the substance, and from the boiling point and melting point we can identify the substance. In addition to this, the thermal methods can be used for quantification of substance. We can determine the amount of substance. Therefore, identification similar to estimation is carried out. Estimation of substance is carried out by recording the loss in weight of a substance. That means whatever the amount of material that is lost, based on that we can quantify the material which is heated in a thermobalance. Therefore, identification and estimation. Along with this, the thermal method can be used to determine the purity of a substance. In addition to the structural composition of the material is measured. Then thermal methods are used to determine the phase transition temperature. Phase transition temperature means a temperature at which a solid is converted into liquid and liquid is converted into gas. In addition to this, we also determine the decomposition temperature of the substance by a thermal method. Therefore, here thermal methods are those methods in which heating and weighing of sample is carried out. During heating, whatever the change in substance, that is loss in weight or gain in weight, is recorded. Similarly, other physical and chemical property of substance are recorded for identification and estimation of sample. Therefore, thermal methods are not only useful for identification and estimation of substance, those are useful for determination of decomposition temperature of a substance, purity of substance, structural composition of the material or substance, as well as the phase transition temperature. All these can be carried out by using a thermal methods of analysis, and here on the basis of temperature programming, that is on the basis of heating rate, the thermal methods are classified into different categories. That is a classification of thermal methods of analysis. Here, classification. Thermal methods of analysis are classified on the basis of temperature programming or heating process or heating rate are classified into different types, and first type is called as thermogravimetric analysis. It is called as TGA. In this case, the loss in weight of a substance is recorded as a function of linear increase or decrease in substance, linear increase or decrease in temperature of the substance. Therefore, first type is called as thermogravimetric analysis. In this thermogravimetric analysis, the loss or gain in weight of substance is recorded as a function of linear increase or decrease That is the first method. Second method is a derivative thermogravimetric analysis. Thermogravimetric analysis. It is called as DTA, derivative thermogravimetric analysis. In the derivative thermogravimetric analysis, the rate of change in weight of a substance is measured as a function of its linear increase or decrease in temperature. Therefore, here thermogravimetric analysis that only related with recording loss in weight as a function of temperature. In derivative thermogravimetric analysis, the rate with which that weight loss takes place, that will be recorded as a function of temperature. That is, change in temperature may be increased or it may be decreased. Third one is called as differential thermal methods of analysis or differential thermal analysis. It is called as DTA. In this case, the transition temperature, the temperature of transition and the temperature of reaction of a substance are determined or measured using DTA apparatus. Therefore, first three types, that is the thermogravimetric analysis, derivative thermogravimetric analysis, and third one is differential thermal analysis. In differential thermal analysis, the temperature of transition, that means temperature at which that substance is converted into liquid or temperature at which liquid is converted into gas, that is called as transition temperature. As well as temperature of reaction. Temperature of reaction means when reaction is taking place, whatever is change in temperature, that is recorded when that is exothermic or endothermic reaction. That means change in temperature and change in temperature, that means temperature of transition and temperature of reactions are measured in DTA apparatus, and that is a differential thermal analysis. Next type, that is a fourth type, is called as differential scanning calorimetry. That is fourth type, differential scanning calorimetry, in which here the heat absorbed or evolved is measured with linear increase or decrease in temperature of a substance. Therefore, differential scanning calorimetry, substance is heated linearly or sometimes it is cooled linearly by changing temperature linearly. Whatever the amount of heat absorbed or evolved by that substance is measured, and that is called as differential scanning calorimetry. Next, number 5, that is called as a thermometric titration. Thermometric titration, and now it is very known to you. Here, change in temperature is recorded as a function of reagent added. Here, change in temperature is recorded as the reagent is added into analyte. That means here thermometric titration. In this case, the equivalence point is determined by recording change in temperature of a sample solution as a function of reagent added. Similar to other titration, if titration reactions are completed, then we have two straight lines intersecting at equivalence point. This is a thermometric titration. Last type of thermal methods of analysis, that is called as gas evolved technique. Gas evolved technique of analysis, and here in this case a thermal conductivity of substance is measured. The thermal conductivity of a substance is measured, and here it is decreases. Thermal conductivity decreases if there is evolution of gas. Therefore, gas evolved technique, that is related with determination of thermal conductivity of substance by using thermal conductivity cell. In this case, thermal conductivity of solid is more than the gases, and if that substance undergo decomposition and there is evolution of gas, then its thermal conductivity is get decreased. Therefore, here on the basis of temperature programming and the parameter measures, the thermal methods of analysis are classified into 6 main categories. That is, number 1 is thermogravimetric analysis. Number 2 is derivative thermogravimetric analysis. Number 3 is differential thermal analysis. Number 4 is differential scanning calorimetry. Number 5 is a thermometric titration, and number 6 is gas evolved technique. Student, this is about the classification of thermal methods of analysis. Now we discuss the first type, that is a thermogravimetric analysis. Thermogravimetric analysis. Student, now we discuss the thermogravimetric analysis. Thermogravimetric analysis and its type. Thermogravimetric analysis is again one of the most important method of thermal analysis. Now in this case, there are 3 basic types of this thermogravimetric analysis. First of all, we discuss thermogravimetric analysis. Its definition. In thermogravimetric analysis, change in weight or a mass of a substance is recorded as a function of temperature or sometime time when temperature is constant in thermogravimetric analysis. The change in weight or mass of a substance is recorded as a function of temperature or time. Time, that means when temperature is constant, when the substance is subjected to a program temperature change in thermobalance at specific atmosphere. This is the definition of thermogravimetric analysis, in which the change in weight of a substance or change in mass of a substance is recorded as a function of temperature or sometimes as a function of time when temperature is constant. When this substance is heated in a thermobalance by using a program heat change or at a specific atmospheric condition. Atmospheric condition means here when that substance is heated, its atmosphere may contain different gases such as inert gas like nitrogen, sometimes carbon dioxide or sometimes oxygen. Therefore here, when that substance is subjected to a program temperature change in a thermobalance containing different types of atmosphere, that means CO2 atmosphere, oxygen atmosphere or nitrogen atmosphere. This atmosphere is required to study that particular substance, decomposition temperature of that substance and effect of decomposition temperature on the basis of the change in atmosphere. Therefore, this is the definition of thermogravimetric analysis. On the basis of temperature programming, these thermogravimetric methods are also classified into three main types. Number one is called as isothermal or static thermogravimetric analysis. As the name suggests, here isothermal means temperature is constant. Static means temperature is constant. Here, change in weight of substance is recorded as a function of time when temperature is constant. Therefore, change in weight of substance is recorded as a function of time when temperature is constant. This type of thermogravimetric analysis is called as isothermal thermogravimetric analysis or static thermogravimetric analysis. Second type is called as quasi-static thermogravimetric analysis. In this case, substance is heated with a series of temperature range for here quasi-static thermogravimetry, in which substance is heated with a series of temperature range in order to obtain that substance to a constant weight. Therefore, till the weight of substance is constant, the series of temperature are increases. Third type is called as a dynamic thermogravimetric analysis. Thermodynamic TGA. In this case, substance is heated by changing the temperature in a linear or a program manner. Therefore, here in this case, in isothermal thermogravimetry, temperature is constant. Weight of substance is recorded as a function of time. In quasi-static thermogravimetry, substance is heated linearly or sometimes with a series of temperature in order to obtain it to a constant weight. And in dynamic thermogravimetry, substance is heated with a series of temperature range. Those are programmed. That means for heating that substance for up to 10 seconds, temperature range is this much, 10 to 20 temperature range is this much, 10 to 50 temperature range is this much. That is called as dynamic thermogravimetric analysis. Student, this is about the thermogravimetric analysis. Its type as isothermal, quasi-static and dynamic. In this lecture we discuss what is volatile thermogravimetry, that is a thermal methods of analysis, classification of thermal methods of analysis and thermogravimetric analysis and types of thermogravimetric analysis. Student, in next lecture we discuss the instrumentation of thermobalance, that is the apparatus required for thermogravimetric analysis. With this we stop here. Thanks for joining me. Wish you all the best. Keep learning. Happy learning.